Section 3 is systems of linear inequalities. And we talked about systems of equalities, systems of equations, in Chapter 3, Sections 1 and 2. Now we're going to talk about linear inequalities. So you're going to have to do these by graphing, because a system of linear inequalities has two or more linear inequalities together, just like the systems that we've been talking about in this chapter so far. In the beginning of the chapter, we found a solution to the systems of equations by graphing, substituting, or eliminating. And almost all of them, more than half at least, had a solution that was an ordered pair. But now, because these are inequalities, our system has solutions that are way more plentiful than just one ordered pair. And so the solution to the system of linear inequalities are a whole bunch of ordered pairs that make the inequalities true. And so in order for us to show a whole bunch of ordered pairs, we end up shading. My recommendation to you when you do questions like this, especially if you have a little bit of difficulty, is to shade them separately and then darkly shade where they overlap. Now this is kind of difficult for me to do on the smartboard, so I will shade one area and then erase it, shade another, and then show you the overlap. So again, you might want to grab 2 colored pencils or 2 light pens or highlighters or something so that you can see the difference. Just make sure that whatever you do, the colors are really light so you can see what else is going on. Taking a look at letter A, they want you to graph. Now, the first thing I notice is that the inequality symbols are there. You have less than and greater than sign. You're going to graph them separately as if only one of them existed. So I'm going to graph that top one in red. It is already in a y equals mx plus b situation, so I am ready to graph it. It crosses at -3 and has a slope of up 2 over 1. It's positive in terms of its slope, and before you draw it in, it should be dashed, because there's no line under the inequality. So here's where the shading comes in. Again, I'll shade the first one, and then I'll erase it, so the smartboard won't allow me to shade more than one at a time. So this one is a less than, which means if you put your pen or pencil on the y-intercept, you want to shade down. So that section that should be shaded for this one, just this line, is kind of to the bottom right side. So take a second and get yours shaded. Lightly. Don't forget to shade them lightly. Now I'm going to erase my shading because the smartboard won't allow me to double up. So for the second one, 2x plus y is greater than 2. That is not ready to be graphed. I'm going to start by subtracting 2x from both sides. I get y is greater than -2x plus 2. This is what I'm graphing. This is a line that crosses at +2. From there we'll go down 2 over 1 a couple of times, and will be dashed as well. There's no line underneath, so it is also dashed. So for the green one, if I do the same thing in terms of shading, this is a greater than, so ignore that first line. Ignore the one that I have in red. You're going to go to the y-intercept, put your pencil down and shade up. So just for the green line, again, I'm ignoring the first one I have there. You should have all of that shaded. So just for the green line, you're doing the upper right-ish of the graph. So if you've done the whole 2-colored thing, you should find that the 2 colors for both the red and the green overlap. So above the green but below the red ends up being this section. So you need to make sure that this section is shaded darker than the rest. That's the solution. Every ordered pair in that shaded section satisfies both inequalities for this question. And that's it. So I recommend you get 2 colors. Shade one lightly, shade the other one lightly, and then darkly, or darker, shade those sections that overlap. So we're going to repeat this process for letter B. If you take a look at the top one, it's already in y equals mx plus b, so I can start by graphing. Go up 5. From there, your slope is a -1, so go down 1 and to the right 1 a couple of times. And then draw it in with a solid line now, because there is a line under your inequality. Take a second while you're drawing that line to point out that none of these are absolute values, which means none of these are v's. Remember, straight lines occur anytime you have x's and y's and it's raised to the first power without an absolute value. So I'll do the same thing I did last time. I'll shade this top one. This one is a greater than, so go to the y-intercept, shade up. So for this first line, you should have all of this shade. Take a second and catch yourself up. All right, I'm going to do the second one in green. The second one is not ready to be graphed, so I'm going to start by adding 3x to both sides. Adding 3x gives me y is less than or equal to 3x minus 4. That's a line that crosses at -4, goes up 3 into the right 1. And when you draw it in, it should be solid because of the line underneath. Now for this second line, when we shade, this is a less than situation. So just for the green, remember you have to ignore the first one to shade the second. So if I go to the y-intercept, less than, shade down. So for the second line, I want all of this. So at this point, if you're using two colors, you should have two colors on your graph and a section of which they overlap. And the region that they overlap in, which is greater than the red one but less than the green, ends up being all of this. So make sure that that area of your graph is darker than the others. Go ahead and pause the video so that you can complete the "you try it."